Well, if you've been flying lately, you have likely felt a little bump in the air. You may have noticed it's feeling a little bumpier. Severe Weather Team 11 meteorologist Danielle Dozier's live tonight after finding out what it has to do with climate change.
Stephen, at any time, thousands of planes are in the air, and some research shows whether you're flying domestically or across the pond, you may encounter more turbulence in the future. If you've flown recently or over the past few years, you may have noticed more turbulence on your flight.
Yeah, there's always a little bit of turbulence.
When I feel like the turbulence and stuff, it kind of wakes me up a little bit. It's kind of scary.
There's reason to believe our changing climate could be the cause. The planet has warmed about 1 degree Celsius since the start of the Industrial Revolution and is increasing 0.2 degrees Celsius per decade, according to NASA. I spoke with Dr. Paul Williams, a professor of atmospheric science at the University of Reading in the UK, who says the temperature is also changing at different altitudes, and it's these changes that can lead to more turbulence.
Ground level, we know that the Arctic region is warming faster than anywhere else on the planet, and that's because as the sea ice melts, the sunlight that used to get reflected back to space is now being absorbed by the ocean, and it's having a warming effect. And so this amplified warming, the amplified Arctic warming, is reducing the north to south temperature gradient that drives the jet stream. That's what's happening at ground level.
However, if you go up in altitude where planes fly, things are different. The tropical regions are warming faster, and this strengthens the temperature change at jet level. It's the strengthening temperature gradient that's leading to more wind shear at flight level, which causes the turbulence. In fact, Williams says there's 15% more wind shear in the jet stream than 40 years ago, based on satellite data.
And what we find is that as we crank up the carbon dioxide in the model, the jet stream becomes more sheared, and we already have satellite observations showing that this process has already begun. And indeed, we find 100% or 200% increases in the amount of severe clear air turbulence at flight cruising levels.
Clear air turbulence is invisible, and it can't be detected on radar. It's the kind of turbulence where you're up there flying smoothly in sunshine, and then it turns bumpy for no apparent reason. There are turbulence forecasts that are issued every 6 hours to help pilots, and are about 80% accurate. But Williams says he wants them to be at 100%. Improving forecasts to help limit the amount of turbulence we're likely to encounter the next time we fly. Williams' research is focused on transatlantic routes in the winter, but he believes more turbulence will also be found over North America, the North Pacific, and Europe. He says the main impact will be the amount of wear and tear on the plane, encountering 2 to 3 times more turbulence. However, he says not to worry because planes are built to withstand turbulence and are routinely checked after flights. Meteorologist Danielle Dozier, Channel 11 News.